All right, welcome back to another video of Chem with Com. Today we're looking at, let's take a look here. Oops. Solutions and empirical formula. This is part one of a three-part video series. These are the topics in the book you can read or go through. Um, this is the topic for this one. This is topic one of three. This one's going to be called mixtures. All right, let's get rolling. So mixtures, we talked about some of this before, but we take a look at whatever we're dealing with, right? And you ask yourself, hey, does it have constant properties and composition? Meaning, um, is it made of one thing or is it made of multiple things, right? If it's made of one thing, and one thing can be a weird term, right? One atom, it can be made of one specific molecule. It can be made with a compound, right? To see if it's a pure substance, right? So if it is a pure, can it be simplified chemically? Meaning, is it more than one type of atom? No. Right? If it's just one type of atom, it's either an element. This is one hydrogen atom. This is two hydrogen atoms. This is a molecule of H2, right? These are very, very similar. It's just the right side is stuck together, but they're still elemental because they're made up of one element. All right. And if we have more than one atom, more than one or more different types of atoms, they're going to be called a compound. We covered all this a few chapters ago. I believe that was, I have to look at it, but you can find it on the spreadsheet on the kind of guide. All right. So now if it's a bunch of things together or more than one thing, so two or more things together, it's some sort of mixture, right? And it could be a combination of this and this, or water and carbon dioxide, or glucose and water, right? As long as it's two different things, that's now a mixture. All right. Now, if you're looking at it, is it uniform throughout? Meaning, does it look like one thing, right? If it looks like one thing, it's called homogeneous, right? And if it looks like two or more different things, that's heterogeneous, right? So let's take a look. So again, it looks like one thing. I'll just write that up there. So looks like one substance, it's homogeneous. If it looks like two or more things, that's heterogeneous, right? And most of this chapter is going to be homogeneous solutions, right? So let's take a look. All right. Mixture, if it's homogeneous, meaning it looks like one thing, it is going to be now referred to as a solution, right? And it looks like one thing. This red Gatorade, boom, all red. There's no bumps, there's no bubbles, there's no little mark particles. Heterogeneous, you can see two different things. These little oil droplets in this one and a red liquid. It's the worst color for that specific thing I just drew. Red liquid, right? And some sort of oil thing, right? So if it looks like two things, like salad dressing or I don't know, like sand and water, right? It looks like two different things, right? They're not solutions. They're not homogeneous or homogeneous. Sorry, homogeneous. All right. So a lot of this has to do with dipole-dipole interactions. So we're gonna go back and review chapter 7 in intermolecular forces. All right, this is the review. If you need help with this, you're gonna go back one. Dipole-dipole attractions are what gets things to mix together or not mix together, right? So we have this term called like dissolves like, meaning Polar dissolves polar. Non-polar dissolves non-polar. Um, yeah. So oil and water do not mix because oil is non-polar. It does not have a dipole. Water is polar, right? It has a dipole. So two different things. So it's not going to mix because polar only dissolves polar and non-polar only dissolves non-polar. They don't, polar will not dissolve non-polar and non-polar will not dissolve polar. So let's look over here. Here we have antifreeze. So over here is what's called immiscible. It does not mix together well, right? You can see the two layers. It looks like a heterogeneous solution. Or sorry, heterogeneous, homogeneous, yeah. And then it looks like a heterogeneous solution. So let's put that in. Heterogeneous mixture. Genius mixture. And we'll probably stop using those words for now. We'll stick to solutions because we're not going to do these anymore. Miscible is when you have something that mixes together well, and polar will dissolve polar. So we have polar water and we have polar antifreeze. You mix those together and you get, it looks like one thing. So this is a solution or a homogeneous solution. Sorry, homogeneous mixture, right? And if they mix together well, they're called miscible, right? Miscible means mix as well. Immiscible means doesn't mix, right? And again, polar dissolves polar, non-polar dissolves non-polar. All right. So like dissolve like, that happens for liquids and solids as well, right? We have water. Again, we're using water as an example. It's a this is supposed to say partially charged molecule, right? Not partially charged molecule, because it has a slightly positive side and it has a slightly negative side. Let me fix that. Slightly positive, slightly negative. So you can split that. So what happens is this partially positive side will stick to negatively charged chlorine ions, and you have that bond between them. Uh, so this is potassium chloride. Um, potassium chloride. Here we have the potassium, which is a positively charged molecule, and if you look at it here, it's being attracted to the negative side of the water, right? So we have the water is a dipole, and these are called ion dipole interactions. Ion dipole interactions. Or I think they call them attractions or something, right? But again, right, salt, sodium or chloride, or in this case, potassium chloride, starts as a solid, but you put it in water because water is a polar substance, it will dissolve that solid, right, into these little ions. Now, what happens if you have something like oil? If you try to dissolve something like sodium chloride in oil, it won't dissolve, right? Try it. Try it at home. Take a little cup of oil, throw some salt in there, and try and dissolve it. It will not dissolve because this is ions. So this is polar and this is non-polar. Won't mix, right? So you could try that. So again, like dissolves like for liquids and other liquids, and like dissolve likes for liquids and solids. Same with gases. As long as they're polar or non-polar, they will dissolve in each other, right? Some things are also what's called partially miscible. Here we have bromine. Let me see if I can get a good pen color for this. So let's just say bromine. I think it's probably Br2. This is non-polar. Here we have water, H2O. This is polar. So this is going to be what's called partially miscible. And that's when you get some brown. You can see the brown color in water. And that came from the bromine transferring, right? Mixing or being partially miscible with that water. So brown color, and that's the bromine, Br2 in water. So some things are partially miscible. So you have fully miscible, immiscible, and then partially miscible, which we have here. All right, well, that's our intro, and I will catch you next time with more stuff, and I'll see you then. All right, have a good day. Bye.